So let's talk about strings real quick. So just as a reminder, we did talk about data types, right? We talked about integers, floats, doubles, booleans, and strings. They're a special kind of data type. It's a collection type. So it takes a collection of characters, one or more letters, right? So there's more things we can do with them than we can with the primitive data types that are numbers, an individual character, true or false. Those are considered primitives because they only do one thing. And a string is a collection of those individual characters. So they could be numeric characters, they could be special symbols, they could be letters, uppercase, lowercase, and it could be 0 to many in this collection. So by having that collection, we then can have ways to operate inside of the collection. So it's considered a object type, so it has functions associated with it. Like the turtle has functions, string type has functions, or the string collection has functions. So we can use those functions to navigate ourselves up and down the string to manipulate the individual characters in the string. Now, why is that important? Because sometimes we need to do things like search the string. Sometimes we need to alphabetize the string, and you can't just do it based on the first character, because, what if you have similar names in your list? So you had to be able to do first letter, last letter, in between letters. Sometimes you want to flip a string and you just want the first part of it or the last part of it. And these are all things you can do with the functions that are built in. And strings are not limited to just short number of characters. You can have a string that is the whole chapter of a book or more, depending on how much memory space you have available to you. So maybe you need to just pull out 2 or 3 words from this really long sentence. You can do that. So every character in the string has a position or an index number. And again, we're computer scientists, so we always start at 0. So the first letter in a string is the 0 index. And each letter goes up by 1 as you move from left to right, just like when we're reading in English. You also can index a string in Python from last to first, but those indexes are negative numbers. I'm telling you about it because it exists. I have never in my life used that because the logic in it just doesn't work for me. I'm so used to everything being index 0, 1, 2, 3. I don't even think about using the negative numbers to come backwards. If you want to and you like that logic, that's fine, because the great thing about computer science, there's no one correct way to do anything. There's always multiple ways to do things. But be aware that they're there. So this string has a name of letters, and I can get an individual letter out of the string by using the square brackets and the index number. So I use the name of the string, because we have to create a namespace for it. And then you use the brackets if you want just a specific location or a specific letter. So in this case, letters includes A, B, C, D, E, F. The first letter is indicated by letters at 0. The last letter is letters at 5. Because there's 6 letters and they're indexed from 0 to 5. Now, that's great because we know how many letters are in our string. If we didn't know how many letters were in our string, we would have to figure that out. The good news is strings have a function that tells you how long they are. But we also can get part of a string, or we call it a slice. We're going to slice off or slice out a chunk of the string. And we can do that by giving it a range. Just like when we were doing the for loops that have a starting and an ending point. Similar here with the strings. Inside the square brackets, you put this where you want to start at and where you want to end at. So if I want the first 3 letters of A, B, C, D, E, F, I would put in 0, 3. Because the first index is included, the last index is excluded. So it gives you 0, 1, and 2, which is the first 3 letters, and it doesn't give you 3. If I wanted just the C and the D, I would put the index of C as a starting point, and I would put the index of E as the ending point because it won't include the last one, but it does include the first one. Why did they do this? I still don't know. I still hate it. Does that make sense? If you want to go from a certain point all the way to the end of the string, you put the starting point in, the colon, and just leave the last number off, and it automatically will go to the end. Yes, ma'am.
I was gonna ask if you were to do the index number for C and then it ends at E, would it be 3, 5?
Yes. Actually, it would be 2, 5. A is 0, D is 1, C is 2.
Oh,
So 2, 5. Or if you're going all the way, if you want all the way through F, you would just leave the number off and it will go to the end. Can't do that. This screen's not working, makes me angry. So we sliced it. We got a substring. A substring is just a part of another string. So if you ever see the term substring, it means you're taking a piece of a currently existing string. Now, you also can use loops to navigate through a string. So say you had a whole list of characters and you want to print them out one character at a time. And so instead of having it print out horizontally across a line, you wanted to vertically print them one letter at a time. You can set a for loop up to do that, where for a variable current char in this case, in letters, which said that for loop is going to do every item in letters. This is a for each loop for each item inside of letters. You have to go back and access your for loop knowledge. I'm going to print out whatever the character I'm currently on is. That makes sense? So in that case, it's going to go and it's going to vertically down the page, going to run through A, B, C, D, E, F, but it's gonna, instead of printing it out as we typed it in, it's gonna print A on one line, B on the next line, C on the next line, D on the next line, E, and then F. So it'll be stacked one on top of each other, because print is on a different line every time. Right? Okay. You also could do the in range one. If you don't want to do a for each loop, you can use in range, and you can put a starting, have I start at 0 and go until you get to a stopping point. In this case, they're going to do exactly the same thing, because we put the length of letters. Anytime you want to know how long a collection is or a string is, you can put LEN, open parentheses, the name of your collection, and close parentheses, and it will return the length, how many characters are in this string. And then you can loop through it using the I index to get each one each time. So these two loops do exactly the same thing. The top loop is much shorter, much cleaner code. If you know you're going to do every item in a collection, use the for each loop. Logically, it's faster. Typing wise, it's shorter. Reading it is cleaner. Will both of them give you exactly the same outcome? Yes. One's just better coding style than the other. And one's slightly faster. Now, when we're dealing with 6 characters, slightly faster doesn't mean anything. But if you were dealing with the characters in a novel, then it might be, that speed might make a difference. So just like with Turtle, there is links that will take you to that one doesn't work. I need to fix it. Somebody remind me to fix that one day. Let's see if this one works. Okay, so the API one works, the overview one does not. I will try to remember to fix these. But basically, the API will have the overview also. So if you go into the API and you talk about strings, they do, well, let's just use a search thing. So string So you can have constants, you can have all sorts of things. You've got formattings. If you want to change the formatting for strings, you've got functions, you can get the length, you can get fields, there's all sorts of things here you can look at, right? Feel free to use this moving forward, because even I don't remember all the formatting structures. Every time I need to format money, or I need to format it where the columns all line up, I have to go look at it and refresh my memory on which number goes where the periods and the slashes and all the stuff needs to go. So feel free to look at this anytime. Back to our PowerPoint. We will probably use functions like count. So I want to count how many times a letter shows up in a string. Much better to use the built-in function than to write a loop when you're trying to check each letter, right? Replace. I give it a letter to look for, give it a second letter to replace it with. Kind of like your find and replace on Word. There is a find, so you can look for the first instance of a letter. Pretty simplistic, so it's usually going to look for the first time it runs into either a letter or a sequence of letters. So for an example, we want to write a function that takes a string and it counts and returns the number of vowels in the string. Sounds pretty simple talking about it. And if I was looking at it, I could just sit there with a pencil and could do it. The code for it, a little more advanced or a little more complex, because first you have to define what a vowel is. So we're going to create a string that's going to hold all of the vowels. So A, E, I, O, and U. I'm not including Y because it's only sometimes a vowel. Gotta love the English language. And then I'm going to create a function called count vowels that takes a word, any word, that as long as it's a string. I'm going to force it then to be lowercase because we only put lowercase vowels in there. So if I force the input to all lowercase letters, I don't have to worry about A and I. You know, when you start a sentence with A and example, any words that start with a vowel, or you use the word I, which is always capitalized when it's by itself, it's still going to count them because I've forced it all to be lowercase inside this function. Count, I'm going to set up at 0. The indentation is wrong on this slide, so don't get wigged out. I just realized that count should line up with word. Sorry. Okay, it's not gonna let me edit it. Never mind. That should be spaced back one. And then we have a for loop for the character in Word I'm working with. If that character is in the string vowel, then I'm going to add 1 to count. When I'm done, I'm going to return count. This is why I tell you not to copy and paste between code and PowerPoint because it reformats everything. So if you're ever using my slides and you decide you're going to copy and paste code from one of the slides into idle, you're going to have to fix a lot of formatting. You would think that Microsoft would make a PowerPoint slide that would handle code since we're a technology company, but they haven't yet. So it's okay. It happens. So does everybody see how we can navigate strings? I haven't really added any new content to you. We're using for loops. We're using if still. We're using strings that we've used before. All I've done is introduce you to the built-in functions for strings to let you manipulate those strings a little bit more, right? So the new thing I want to add this week is all about lists. Lists are also collections, except they don't have to be characters. You can have a list of objects. You can have a list of primitive data types. You can have a list of lists. You can have all sorts of things in a list. But it's where we want to put a collection of items together. So you can define a list by giving it a name, setting it equal to, and then using the square brackets to hold your list items. Each list item is separated by a comma. So the first example up here is a list of names. I'm going to give it a name. Names is equal to John, comma, Sally, comma, Greg. So now names holds John, Sally, and Greg. It has 3 items in it. Their index numbers are 0, 1, and 2. Just like with a string. You also can have a list that would hold grades. Since John, Sally, and Greg are names, those are strings. I put quotation marks around them to indicate that they're strings in the list. If you leave the quotation marks off, it's gonna try to see if you have a variable with that name and put that variable into your list. Right? A lot of perplexed looks. Y'all are gonna have questions for me on Thursday, right? You're gonna process and you're gonna ask good questions on Thursday. Okay. You can ask them now, but definitely gonna hit me up with questions on Thursday, right? All right. So it doesn't have to all be the same data. I could put in a name, then a grade, then a name and a grade into the one list. I would just have to know when I got ready to use that list that every other one is a number. And the alternate ones are strings and know how to get our information out. I personally wouldn't do this because I would probably forget what I stored in that list, right? But you absolutely can do it. You also can have lists inside of lists. So I could have a 2-part list for each of the elements in my student list. So each student would have a name and a grade. We're going to eventually talk about something called tuples and dictionaries when we get a couple more weeks in, which are much more complex lists than sublists, but it can be done. Dictionaries is a much better way to do it. So you access the elements in the list the same way you access a character in a string by index number. They also too can be reverse indexed. So the last one could be -1. Since there's no -0, you can't use that. So I'm telling you it's there. I'm not suggesting you use it. You're going to confuse yourself, or you're going to forget and leave a negative sign off, and it's going to give you not what you wanted. That's just my personal opinion. You can do as you wish. They do have slicing operators, just like the string does, where you put in the starting index and one past where you want to end, and it will slice up a list and create you a new list. As long as you save it into a new variable name, you can have a new list. Yeah.
So would, if you were to do print names -2, would that be Sally?
Yes.
What is?
So if you were doing the reverse indexing, if this is 0, 1, 2, but if you do the reverse, this is -1, -2, -3.
There's no -0.
There's no -0, so you can't use 0 again. Because 0 is 0. That's why I don't use it. I find it just one more thing to confuse people. I have to mention it because it does exist, and there will be somebody in your life that does this. But you need to know it exists. Somebody that has programming experience or has done other classes may have a different opinion. They may think it's perfectly legit to do it this way. To me, it's just my brain doesn't like it. It's just not how mine processes. You can use for loops to iterate through. Use a for each loop if you're going to touch every element in the list. If you're only going to touch a subsection, use the for in range. Yes.
I was gonna ask for the list. I know you said like on the slide before this one
Mm-hmm.
that you can have different variables in the list, like you could have names or you can have numbers.
Mhm.
So how do you know what lines up when you match?
You just have to know when you create it. That's why I'm saying that it's not necessarily a good idea to mix your data, because the only way you'll know what's in the list is by either printing the list out or being the one that created it. Yeah, I don't know of another language that lets you mix items as much as Python does. Because Java wants you to tell it what's going to be in the list. It can be objects, but it can't be a primitive data type and an object. It just doesn't work quite that way. But loosey goosey programming, Python. But just remember, for each loop, if you're touching every element for I in a range, if you only want a subset of the list. N is considered a operation that's going to give you a Boolean answer. It's either in the list or it's not in the list, so it's going to give you true or false. You absolutely can look for an element in a list by using the keyword in. If it's there, it's going to return true. If it's not there, it's going to return false. If it's there more than once, it's only going to return true. It's not going to give you a count of how many times it's in the list. If you go to the API, there's a whole list of functions that go with lists. You're going to need them for the labs and the assignment. You can use a plus sign or an addition operator on lists. You can take two lists and add them together. And what you get is a third list. It takes the first one and then it jams the second one up right behind it. No sorting, just one list followed immediately by the other list. But it does create a new list. So if you don't set it equal to something, it goes away. So you need to store it in a variable. Like when you're getting input from the screen, you have to put it in a variable. You create a new list. If you want to keep it, you have to put it in a new variable. Or back in the same variable. But if you do that, you've overridden one of your original lists. When you do that, the original two lists are unchanged. The new list is in data in this example, but names and grades have not changed, and you still can use them as names and grades later in your code. You can append, which means I'm going to add one to my list. You can use the function append, and it will put the new item at the end of your list. Why would you want to do that? Because you're always adding new people to your classes or new people to your database. So you often will use append to add things to a list. Here's an example of some of the list functions. Is that big enough to see in the back? Okay. So append is always going to add it at the end. If you use insert, you give it a position, what index you want to put it in, then the item, and then it will insert it at that position. So if you know you want it to be in the third position, you put in the index 2, comma, whatever the item is, right? Pop is an old way of doing things. It's going to take the last item in the list out of the list and return it to you. So it not only returns the value where you can print it or whatever, it is removing it from your list. This is an old stack or queue way of doing things where last in, first out, you pop it off. There is a second pop that takes a position where you can go and get a specific one and remove it. Don't see a lot of people using pop so much in lists nowadays because there's this remove function that's newer and more clear what it's doing? You can sort a list. It will, it doesn't take any parameters. It just sorts the list. Either if it's numbers, it sorts it numerically. If it's, characters, it sorts it alphabetically. You can reverse a list, so if you don't want it to be from A to Z, you can use reverse and create a Z to A list. If they're not sorted, it just reverses them as they are in the list. So instead of John, Sally, Greg, you can reverse it and have Greg, Sally, John. The function index will tell you the position of a certain item in the list. So we did index, open parentheses, Greg, close parentheses, it should return 2. So it'll return the number, the numeric index for where that item is. Count will count how many times whatever you put in the parentheses happens. Remove does exactly what it sounds like. It's going to remove that item from your list. Are there more? Yes. There's link and well, I can't think of them off the top of my head, but there's a bunch more things you can do to lists. API is your friend. Go look it up anytime. Let's see if this link works. Maybe not. Oh, in the background. Yep. So you have append, extend, insert, remove, pop, clear. You can empty the entire list. Reverse, you can copy a list. And then it gives you examples of things you can do and how to use it in the code. If you're not using the API, you don't know what you're missing because it absolutely will give you great things and great examples of how to use certain things if you don't know how to use them. Google is also your friend. You are more than welcome to look up a list function. Do not ask ChatGPT or Copilot to write your code for you. It never goes well for you in the end because I either figure it out or you miss all those questions on the test. Finding the min and the max in the list, there's actually a function that will tell you the minimum number in a list and the maximum number in a list. I think it also works on characters, so it would probably alphabetically give you the smallest and the largest.
Reading says the greater than less than.
You can compare letters. You can compare letters greater than or less than because the computer sees them as their ASCII binary representation. And oddly enough, A is a lower number than B. But capital A has also got a different number than a lowercase a. So you need to be careful of that. So you can use greater than or less than comparisons on strings and characters. Just be aware when you do it that uppercase and lowercase will change your results. That's why when I do comparisons on strings and characters, I generally force it to either be uppercase or lowercase. I just force all the characters to go one way or the other because that eliminates one of the error factors. You can create, since you know max and min, those are functions already there. One thing that you often have to do with a list of numbers is get the average. That's pretty simple to do with a for loop. You just loop through each one, creating a sum of all the numbers, and then divide it by the length. Pretty common thing you see is where you have to average. Excel does it really quickly for you. It has a little button, does it for you. So it's basically a loop where it goes through and it says, I'm going to take the first element and add it to the second element, then I'm going to add the third element, then I'm going to add the fourth element, and then I'm going to divide it by however many elements I have in my list. You might actually see some of that on your lab and your homework. Just saying. Next class, we're gonna talk about files. So, like I said, the lecture is pretty short for today because it's really just using functions on collections. Does anybody have any questions I can clear up today? If not, I will see you Thursday. We will do a lab together. I'll code, you'll copy, you'll ask me intelligent questions, you'll ask me unintelligent questions. I don't care. It's a whole lot more fun when you ask me questions and we interact together. So come prepared. It'll be a little bit longer lab than we normally have, so be prepared to go the entire period.
Have a good day.
You too.